Okay, sir. This is the fourth one. It is to explain the case IEEE 33 bus with the GWO to optimize the configuration of the network of IEEE 33. This is optimized. The parameter of optimized it is the line, which is line it is connected and which is not connected. It is dependent on the configuration of the network. So and dependent on the object function. So the first thing it is to clear CLC, and after that we identify the load flow. It is as a cost function or object function, and then we initialize some parameter for for GWO, like the maximum number of iteration, the number of particles, and the number of variables. As you see here, it is 37 parameter. This is the number of line that in IEEE 33 can be connected or disconnected. And after that we as you see here, we call the GWO gray wolf optimization with the input and output. The gbest, it is the which line it is open. This is mean which line it is open, and this is the convergence curves, how the fitness or object value behavior with the iteration or during iteration. And then GWO, it is in the name of function, and then we have the input, the number of particles, maximum iteration, the cost function, and the last one it is the number of variables. And after we finished from the GWO, now we get the result and print it on the screen, which switches it is on or off. That mean which is line is on off, it is open. Then the power loss, the reactive power loss, voltage deviation, voltage stability index, and the total system cost. This is the printed, and after that we also printed the figure of the convergence curves, how with the iteration, and the figure of voltage profile, and then also figure of the system profile, how the load PV generation distribution grid, and the last one it is the load profile for EV and losses, how behave. It is the same the same that we get it in base case. The same thing it is now. This is the main program that we can run the program from here, but the other file it is the same thing, the load data of the IEEE 33, the line data, the specification of networks, and also the profiles of the real load and reactive load, and the PV distributed generation 1, distributed generation 2, AV profile, and distributed cost. And this is and the same thing as the load flow here. It is the load flow, and we can get it the fitness value and the power loss, reactive power loss, voltage deviation, the voltage profile, voltage stability index, total cost, and the power loss for each hour, for each buses. As you see here, or for each hour, sorry, the same thing. And explained before, initial parameter accumulated some initial parameters, and read it the profile, and define some other parameter like PV generation price, grid imported price, and this is the account number that we used in the our optimization, and this is the new. And this is as you see here, this is the reconfiguration code, how to reconfiguration, depending on if it is more than 0, that mean it is closed. But if less than it is if the equal 0 or less than 0, that means the line it is open, and we here to determine which the line it is open from here depending on the x that we that is input of the load flow from the optimization process. And after defined which line it is open, after that we go to the validation process. Validation process, it is check if the all path it is or all load connected with the source of energy. That mean the load can be covered from the source and connected, and the each load can be covered from the generation source. This is the validation process. If not, as you see here, we put it some penalty factors. If the network or some load does not covered from the generation, or the load does not covered from the network. And after we finished the validation process, now started with the preparing datas of the network, and started the load flow as we explained before. As you see here, put it where is the EV, AV, and the PV distributed generation 2 and 1, and then we started to arrange the network as a radial network, and how much path, and how the load it is connected with the source, and then we calculated the voltage current program. First assume the voltage bus it is 1, and then we calculated the current, branch current of each line, and after that we calculated the bus voltage and repeated the process 5 times, and then we calculated the losses and real losses, reactive power loss, voltage stability index, and the minimum voltage and maximum voltage. If exceeded this limit, we put it some penalty factors, and then we calculated the voltage division, power loss, accumulated voltage supply, voltage profile, voltage division, voltage stability index, and the generation. And after we finished 24 hours, now we calculated the fitness value. It is dependent on the power loss, the total stability, total system cost, and the voltage stability index. As you see here, this is the fitness value that we program optimized this value to be minimized as much as possible. And then we go back to the GWO as we explained later. I will explain later. I want to concentrate about this reconfiguration program until here, like this, before preparing data. This is also I will explain again, and depending on the input from the optimization in this program, we determine which the line it is open, and after we opened that, then we make some data validation to check if the network it is connected with each other, and it is the source the load can cover from the source in different path. If the data validation network configuration it is okay, so the program will start the load flow. If not, the penalty factor will be added here to exclude this solution from our optimization. That's it for this load flow program. In the next video, we will go to the GWO to explain how the program it is work in the process. Thank you very much for your listening. If you have any question, it is as you mentioned before, we are ready to answer you, and you are free to ask anything if you don't understand any line of the program. Thank you very much.